Hello and welcome to my video, lesson 3.3, where I talk about standard to vertex form conversion. So just a reminder from previous topics, here is our standard form, okay, and here is our vertex form. And so they both have their functions, both are good for different reasons. Standard form, for example, gives us our intercepts. However, the vertex form gives us our vertex, and both give us the stretch factor, which is the given by the A. Given by A. And that's the same A. Okay, and that's interesting because, well, you can see in a moment why it'll be interesting, why it's important. Okay, so before we talk about how we can convert between the two, we're going to have to take a look at some perfect squares. So that we remember what a perfect square is. And here, if we take a look at these numbers, we can see that they are all numbers that are, or that can be square rooted with a whole number. Okay. Or another way to say it is that there's two numbers that multiply, or the same number multiplies by itself to get the answer, right? So these are all of the ones that you really should have memorized just off the top of your head. You should be able to just right away tell when you see one of these numbers and go, oh yeah, that's a perfect square. Okay, so polynomial perfect squares. If you have a perfect square to begin with, that's fantastic, right? So if you have a standard form where you have it like this, plus 2x plus 1, it's already in a perfect square. So when you factor it, it's x plus 1, x plus 1, or another way to write it is y equals x plus 1 squared. Okay, so if it's already in this form, that's fantastic, because you can right away go to vertex form. Okay, and here you can tell that it's a plus 0 for our q value, but it is a plus 1 in here. Okay, that's nice to know, but if we take a look at all the different polynomials perfect squares, let's see if we can find a pattern. So let's go through and see if there's some sort of pattern. So here we're going to have 6x plus 9. Here we're going to have 8x plus 16. Okay, so do you see a pattern here? So if you take the 1, we get 2. If you have 2, you get 4. If you have 3, you get 6. Okay, maybe you might start seeing a pattern. Okay, so 1 you get 2, 2 you get 4, 3 you get 6, 4 you get 8, 5, right? We'd get 10, 12, 14. Okay, so what's the pattern? Well, if you take that number and you just times by 2, it equals that number. Okay, so that's one pattern. So just multiply the number by 2 and you get the degree 1 term. And what about another pattern? Let's see here. Take the 1, you get 1. Take the 2, you get 4. 3, you get 9. 4, you get 16. Wait a second. These are perfect squares, right? And they're squares of the number that you had at the beginning. So to get the green number, you multiply by 2. To get the red number, you square it. Okay, so those are the patterns there. I guess the constants, I guess I should write down, you square it. The coefficients, well, the first one here is just based off of the first value, so that's kind of the same. But the second one is a times 2 value. Okay, so let's try this out now. What would we do if we got some of these questions for ourselves? How would we solve them? So we want the following to be in vertex form. What we're going to do is we're going to take this number and we're going to divide by 2. Okay? Then we're going to take that number and we're going to square it, which will give us 16. Okay. So what this all lets us write down is that y equals x squared plus 8x plus 16, but it still has to equal the plus 12 from before. So we're going to have a minus 4. Okay, so just in case that's not clear, this gives us the 12 from before, and the rest of it gives us now a perfect square that we can factor. So the rest of it is a perfect square we can factor. So this, if you remember, if we divide by 2, we got 4. This is going to be plus 4. That's from right here. Squared minus 4. And that's from right here. Okay, so we took this part here, and we're able to factor it into our perfect square, and we took the minus 4 and we put it after. Alright, so that's our vertex form for one option. Let's try another one. So let's try another one. Same sort of process, but first what we have to do is you know what, this is not a good number here. I thought I put like, let's go 24. Okay. I made a mistake. I don't know what I was doing. Okay, so first what we have to do is we have to take out greatest common factor. So 4x squared plus 4x minus 6. Okay, and just a reminder, guys, you can always pause the video and try it out for yourself and then see what I do. Okay, and then the rest of it's the same. So take this number, divide by 2 to get our square number, and then you square it. And that gives us our new number. So what we need here is, so y still equals the 4. Okay, the rest of it is going to be in brackets. But the rest of it is x squared plus 4x plus 4. So to get that, we're going to have to, instead of, what we'd have to have is a minus 10 in order to make this work out. So this plus 4 minus 10 still has to be the negative 6 from before, so that it all evens out and it's all still the same. Okay, now what we're going to do is take that square number that we had before, so we'll still have the 4 outside the brackets, but now we're going to have x plus 2, and that's from right here, squared, minus 10, and that's from right here. Okay, and then we're going to multiply the 4 into our brackets. So, whoops, undo that. Okay, multiply it in here, and multiply it over there. So that's just going to give us a y equals 4x plus 2 squared minus 40. Alrighty, so those are those two vertex form questions. Now let's take a look at another method of getting there. So another method, so one is by kind of going by completing the square. The other method here is that we can use the formula. So the formula here is P equals, or the x value of the vertex equals negative b over 2a. So if we keep in mind the a and b are from the standard form, okay, and if we keep in mind that the p is going to be going over here. Okay, so maybe I'll highlight that actually. Okay, the P ends up over here. The A ends up over here. And finally, the Q ends up over here. Okay, so the Q is our Y vertex, and the P is our X vertex. Okay, so now let's try to try this out. So what we're going to do is use that formula to get P, and then once we have P, we can put it back in into our standard form and get the Y value at the vertex as well. Okay, so let's try that out right now. So P equals negative B over 2A. Okay, now that we have that, let's try to solve it. So B is negative, so we have 6, so negative 6, and 2A, well, A is 2, so 2 times 2. So we have 2 over negative 3 is how we can simplify that. Okay, and then we can just plug this value back into our formula to solve for the Y value, so or the Q value. So 2 negative 3 over 2 squared plus 6 negative 3 over 2 minus 7. So we're going to have, you could just plug this in your calculator. That would be certainly one way of doing it. 9 over 2 plus minus 9 minus 7. So that's going to be 4.5. So negative 16 minus or plus 4.5. I'll just write that down so I don't make a mistake here. So we'll have negative 11.5. Okay, so that is our Q value. So now we can just write it back into our formula. That's it. So Y equals A is the 2 from here, right? Then X minus P, well, P was the negative 3 halves squared, plus Q, which is a negative 11.5. Because there's a negative and a negative, we're going to make that positive. So that is our equation. One last try here. Let's try out to get P. So negative B over 2A. So again, negative 12, 2A, so we're going to have 6. So this simplifies down to negative 2. So now let's plug that in. That's going to be much easier than the last one. Q is 3, negative 2 squared, plus 12 times negative 2 plus 20. So for the first part, we're going to have 4 times 3 is 12, plus, nope, that'll be a minus 24, plus 20, so that'll equal 16. Okay, so we have the P value from before, we have the A value from there, and the Q value from below. So now we just need to fill that in. So 3x minus a minus, so it's plus 2 squared minus plus 16. Using the formula that's at the top of the page right now. Alright, I hope this video helps you understand standard to vertex conversion a little bit better. Good luck!